Hello friends, welcome to Coding Host YouTube channel. In this video, I will explain a problem. Search a 2D matrix. So in this question, we will have a 2D matrix which is sorted. You can see all its row and column are sorted. This first row, second row and third row is sorted. And this first column, second column, third column and fourth column, it is also sorted. So in this question, we will get this sorted matrix and we will get an element. So we have to traverse in the matrix and we have to check that if this element is present in the matrix or not. So when we are traversing in the 2D matrix, we always use a nested for loops, first for row and second for column. Because of that, time complexity of that program become big of m into n, where m is the number of rows and n is the number of columns. So we have to avoid that nested for loops. We have to use a different type of approach here because this matrix is already sorted, so we have to take advantage of that. So in this question, first I will write the program and then I will explain you the dry run of the program, so then you will understand that how that approach is working. So in this program, first I will make two variables, int row equal to 0 and column equal to. So initially we have to start from here where we have this element 7. So this is our first row, but this is our last column, so we have to start this index from here. So column equal to matrix of 0 dot length minus 1. Then I will take a while loop while row is less than a dot length and end column is greater than equal to 0. So you can see that why I am writing this row is less than a dot length. So initially we are in the first row, we can only move down, we cannot move up because already we are in the first row. And suppose if we are in the last row, from that we cannot move down, so that's why we have to use here row less than a dot length. And for column, you know that we are already in the last column, so here column will decrement, so that's why I have written here column greater than equal to 0, because in the last we can only reach to the first column which is present in the index 0. So in this approach, we only have two type of direction, whether we can go left or whether we can go down. So I will write here if array of row and column is less than target. So in this if statement, I will write row will increment. Then I will write here else if array of row and column is larger than target. So what I will do, I will write column minus minus, and else it means that we have found our element, so that time we will return true, and outside of this while loop I will return false. And let's run this program. You can see here we are getting error, yes, because array name is matrix, we have to use here matrix everywhere. So now let's run this program. Now you can see this program is working fine. Before we submit this program, first we will see the dry run of this program. So you can see that we have a matrix in which you can see how many elements we have, 3 rows and 4 columns. So 4 into 3 is 12, so we total have 12 elements, and we have to check that if this target element is present in this matrix or not. So I have taken this two variables, row and column. So this row is at here at index 0 and this column is present in the last column at 3, so 0 and 3. So you can see how this while loop will going to work, because we are only using a single while loop. So because of that, you can see our time complexity will become big of m plus n instead of big of m into n, which is a huge optimization for this program. So this target is 3. Initially we are starting from this index 0 and 3, so then this value will check if row is less than matrix dot length. Yes, row is 0 and it is less than matrix dot length, and column is also larger than or equal to 0, so yes, it is larger than 0. So then it will check that if at this index 0 and 3 element is less than target. You can see at this index 0 and 3 element is 7, so is 7 is less than target? You can see no, it means that our element is present in this first row, so we do not have to go in next row, we only have to move the column. So then what we will do is we will decrement our column, because in the starting we are in the last column, so then column will become 2. So then we will reach here at index 0 and 2. So again this value will check is element is less than target. you can see element is 5 and 5 is not less than target, so it will not going to execute. Then this else if statement will execute because this element 5 is larger than target. Yes, so column will decrement, so what will happen, column will become 1. Now it will check that if at this index 0 and 1 element is less than target, you can see no, element is larger than target, no, because element is 3. So this first if and else if statements are not going to execute, only this else statement will execute. It's mean that that element is equal to target, so then we will return true from here and this program will stop here. So this is a small test case. Suppose if we take a next example that our target is this element 60. So you can see that in this array total how many elements we have 12 elements. It's mean that we have to start from this first index and then we have to go here on the last index to find that if we have 60 or not. So it will take how many traversal, so it will take total 12 traversal, which is equal to big of m into n. So big of m into n, so m is the number of rows, so which is 3, and n is the number of column, which is 4, which is equal to 12. But you can see here, instead of using that nested for loops, if we use this approach here, only this single while loop, what will happen, so this row and column will start from index 0 and index 3. So it will check that if at this index we have element 7, so 7 is less than target. You can see yes, because 60 is larger than 7, so we have to move in the next row because here we have 7 and 7 is the largest element of this row, and if 7 is also not larger than the 60, so we can find the element maybe which is larger than 60 in the next row. So that's why we are incrementing row now, so row will become 1. So now we are at index 1 and 3. So at this index 1 and 3 element is 20, so is 20 is less than target? Yes, because 20 is the last element of this row, which is the largest element of this row. We cannot find any element which is larger than or equal to 60, so then we will increment our row, so row will become 2. Now you can see here at index 2 and 3 we have 60, so here we will return true and this program will stop here. So here you can see how many travels we have needed, only 3 traversal from index 0 and 3, then 1 and 3, then 2 and 3. So you can see using this single while loop approach, we are able to optimize our program time complexity from big of m into n to big of m plus n. So you can see that actually this is 3, and if we add this m plus n, so m is 3 and n is 4, so it is equal to 7. So we can see that this approach will maximum take big of m plus n time complexity, and this approach will only work for the matrix which is sorted. So now we will submit our program. So you can see that this program is working fine. It has submitted successfully, and the time complexity of this program is big of 1. So thanks for watching.